Hi everyone, welcome to today's lesson. We're going to be talking about surface area. You are going to want to make sure that you have a formula sheet nearby because we're going to be using a lot of formulas that are provided on that formula sheet. You don't have to memorize them, you just need to know how to use them and know how to find them when you need them. Okay. So we're going to be talking about surface area of cylinders, prisms, cones, and spheres, just to name a few. Let's start with our rectangular prisms, or even cubes, because this works for cubes also. So the first example says to find the surface area of each prism, and these are rectangular prisms. So just a little review of what a prism is. A prism is a three-dimensional shape that has congruent and parallel faces that are connected by rectangles. Okay. And our rectangular prism just happens to have a rectangular base. The formula on your formula sheet says that the surface area is 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. Okay, and now let's just for a second talk about what surface area is. Surface area is the area of all of the surfaces added together. So in your rectangular prism, that is made of 6 rectangles. The length times the width represents the bottom. The area of the bottom is the same as the top, which is why it's being multiplied by 2. The length times the height is representing these, hold on, pointer. The length times the height is representing the area of each of these rectangles, the left and the right side maybe. And there's 2 of them, which is why it's being multiplied by 2. And then the width times the height is the area of this rectangle, and there's 2 rectangles that are that size, so that's why it's being multiplied by 2. Okay, so if anyone's asking you to find the surface area, it's asking you to find the total area of all of the surfaces. And sometimes you could find the area of each surface and then add it together, or you could just use the formula. And sometimes the formula is just easier. So in this picture, we're going to label your length, your width, and your height. So I'm going to call this 7 feet my length, this 13 feet my width, and the 9 feet the height. Could you have labeled it differently? You certainly could have. Multiplication is commutative and addition is commutative. So whether or not you called the 7 the length and the 13 the width, or vice versa, we're going to get the same answer. So the surface area is equal to 2 times 7 times 13 plus 2 times 7 times 9 plus 2 times 13 times 9. Okay. And what I'm looking at here, okay, this 7 times 13 is the area of this bottom piece. The area of the bottom piece is the same as the top, which is why it's being multiplied by 2. It accounts for 2 rectangles that are that size. Then this 9 times 7, or 7 times 9, 7 times 9 is the area of this rectangle. And there's 2 rectangles that are that size, which is why it's again being multiplied by 2. And then the 13 times 9 is the area of this rectangle. And there's 2 rectangles that size, so we can multiply it by 2. And the sum of all of the areas will be the surface area. So we type these into our calculator. 2 times 7 times 13, 2 times 7 times 9, 2 times 13 times 9. Add all of them together and we get 542. This is an area, it's a surface area, so our units are units squared. Simple as that. Okay, so if it helps you to list out what is the length, the width, the height, or just label it in your picture, either way, you just plug those numbers into your formula, which will tell you the total area of all of the surfaces. Go ahead and try number 2. Try number 3. Do that now. Right, so for number 2, you should have 580 centimeters squared. And for number 3, 183 inches squared. You can go ahead and double check your formula with mine if your answer doesn't match. Let me know if you have any questions. Now, what happens if it's not a rectangular prism, but it's some other prism? Again, a prism is a 3-dimensional shape with parallel and congruent faces. Okay? They may or may not be rectangles. So this first one in example 4, this is a triangular prism. And I know that because its bases are triangles. I have 2 triangles that are parallel and congruent. Okay, the bases are the parallel and congruent faces. Maybe you want to write that somewhere. The bases are the parallel congruent faces. So many students want to tell me that the base is the shape that the 3-dimensional shape is sitting on. No. It doesn't matter what shape it's sitting on. The bases are your parallel and congruent faces. Okay, so looking here, the bases are triangles. So if it helps to write that somewhere, you can write triangular base or base is a triangle. Okay, you're welcome to do that. The formula for the surface area of any prism is the height of the prism times the perimeter of the base plus 2 times this capital B. Capital B is the area of the base. The good news is, if you don't remember what those things stand for, there's a key on the formula sheet that tells you all of that. Okay. Over here, it says the lateral area is H times P. Lateral are the sides that aren't the bases. So if I wanted the lateral area of this prism, that would be the area of the rectangles that make up the sides. So lateral means side. So the lateral area is the area of the sides. The surface area is the area of the sides plus the bases, all of the surfaces. Okay, so H is the height of your prism. Okay, that's the distance between the bases. The perimeter is the perimeter of the base, and the capital B is the area of the base. So if it helps you to redraw the base, be my guest. Our base is a right triangle. I know that the hypotenuse of that is 15. The legs are 12 and 9. Okay. So to find our surface area, I'm going to have the height of the prism. The height is the distance between the bases over here, 16. The perimeter of the base, we're going to add these 3 numbers together, 9 plus 12 plus 15. So the perimeter is 36. Plus 2 times capital B. We need to find the area of this triangle. Okay. Well, remember, we learned how to find the area of a triangle. The area of a triangle is 1/2 times they use lowercase b. See the difference? Okay, this capital B is the area of this entire base, whereas this lowercase b is just the length of the base of this triangle times the height of this triangle. Okay. Remember, we learned that the height and the base are perpendicular, no matter how the shape is facing. So the base is 9 and the height is 12, or the other way around. You could have said the base was 12 and the height was 9. You just look for the perpendicular parts to find those 2 numbers. And whether you said 9 and 12 or 12 and 9, it doesn't matter because you're going to multiply them anyway. So the area of this base is 54. That's your capital B. So in your formula for surface area, that's what you plug in for capital B. So now you could just calculate this. 16 times 36 plus 2 times 54. You should get 684. This was a surface area. That means our units are squared because it's an area. Okay. Let's do number 5. Thinking about what is the definition of a base of a prism, what shape is the base of this prism? If you said the base of the prism was a rectangle, you're not correct. Remember, the bases of your prism are your congruent and parallel faces. If you said rectangle, there is no other rectangle here that is parallel and congruent to that. So that is not the base. No matter how the shape is facing, you're looking for the parallel and congruent faces. So if you said that the base was a triangle, you are correct. So in this, the base is a triangle. Parallel congruent faces are the bases. Okay, so you could picture it as like the example in number 4, and it fell on its side. All right, so your base is a right triangle. Well, we don't know it's a right triangle. It's a triangle. We know this is 12. We know this is 10. We know this is 5, and we know its height is 4.1, all from the stuff that's labeled in the picture. So for our surface area, that's going to be the height of the prism. The height of the prism is the height between the bases. What is the distance between these two triangles? 3. Then we need the perimeter of the base. The perimeter of the base are the sides of that triangle added together, 5, 10, and 12. So 15 plus 12, 27. So the perimeter is 27. Plus 2 times the area of the base. The area of the base, well, that's the area of that triangle. 1/2 times the base times the height of the triangle. So look for your perpendicularness, your right angle. Here it is. Your height is 4.1, and it's perpendicular to 12. So the area of the triangle, which is the area of your base, ends up being 24.6. So that's what's going to go here in our formula. So we type in our calculator, 3 times 27 plus 2 times 24.6, and our final answer is 130.2, and then your units are kilometers squared. Okay. So the part that messes students up the most on problems like this is they don't identify the shape of the base correctly. It is imperative that you remember that your bases are your parallel congruent faces. Doesn't matter what it looks like it's sitting on. That doesn't make a difference. Your parallel congruent faces are the bases of your prism. Looking at number 6. Okay, number 6, what shape are the bases here? If you said that the bases were trapezoids, you are correct. If you did not say trapezoid, you need to go ahead and double check that, okay? The bases are your parallel and congruent faces. The only 2 faces that are parallel and congruent are these trapezoid sides. So your base is a trapezoid. Now that you know what the base is, go ahead and see if you can figure out the surface area of this trapezoidal prism. Do that now. So the surface area for your trapezoidal prism should be 1,587 feet squared. So let's just talk about those numbers here real quick in case you didn't get it. Remember, the height is the distance between the bases. So your bases were these trapezoids. The distance between them is 15 feet. So your height is 15. The perimeter is the perimeter of the base. So looking at one of those trapezoids, you've got a 12, a 23, 20, and 18. So you add those together, and that will give you the perimeter of that trapezoid. So the perimeter is 73. Then we had to find the area of the base. The area of the trapezoid, the formula was 1/2 times the height times the sum of the bases. So if you're looking at just the trapezoid, the height is 12. That's perpendicular to the bases 18 and 23. Okay, and those are lowercase b's because they're bases of your 2-dimensional shape. This capital B is the area of your two-dimensional shape. So the area of the trapezoid is 246. So then for your surface area, it's the height of the prism times the perimeter of the base plus 2 times the area of the base. So double check your numbers, make sure you got the answer. On any of your assessments, please don't enter commas. I know you were taught at some point that it's 1 comma 587. That comma is going to mess up the computer grading part of OMHS. So no commas. Okay. Here's another example with a prism, and we're going to find its surface area. Looking at this prism, what shape is the base? The base is a trapezoid. You've got two trapezoids that are congruent and parallel, and they are connected by a bunch of rectangles. So again, it doesn't matter what shape it's sitting on. It's the parallel congruent faces. Those are the bases. So the base is a trapezoid. Okay. Knowing that, try this one. Can you find the surface area of this prism? Try that now. So you should have gotten about 833.2. Your units are millimeters squared. So let's just talk about where all these numbers came from. Hopefully this is getting easier. Your bases were trapezoids. Those were the parallel and congruent faces. The height of your prism is the distance between those two trapezoids. The distance between those two trapezoids was 9. The perimeter, that's the perimeter of your base, or the perimeter of the trapezoid. Well, you had a 10 here, 13, 18 was this base, and it said that this was an isosceles trapezoid, which means that this side is also 13. So the perimeter of that base, or the perimeter of that trapezoid, is 54. Then we had to find capital B, or the area of that trapezoid. And the formula for area of a trapezoid is 1/2 times the height. Well, the height of the trapezoid is here. That's our perpendicular line to our base. So the height of the trapezoid is 12.4. The bases of the trapezoid were 18 and 10. So the capital B, or the area of the trapezoid, is 173.6. You take all those numbers and you plug them into your surface area equation. The height times the perimeter of the base plus 2 times the area of the base. Let's look at number 8. What shape is the base at number 8? The base is a triangle. You have two triangles here that are parallel and congruent. Those are the bases. The base is a triangle. All right. So what is the height of the prism? 21. It's the distance between your two bases. Let's find the perimeter of the base. Uh-oh, we're missing a side. Right, here's the base. You have an 8 and a 15, and we know this is a right angle. Pythagorean theorem will help me find that hypotenuse. I'm so glad we learned the Pythagorean theorem. Hypotenuse squared equals leg squared plus leg squared. So that means that x squared is equal to 289. Take the square root of both sides. Our hypotenuse is 17. Now I can find the perimeter of the base. 15 plus 17 plus 8. So the perimeter of my base is 40. Now I need to find the area of my base. My base is a triangle. 1/2 times its base times its height. Okay, remember base and height are perpendicular. So the numbers that I need to use here are 8 and 15. Those are the perpendicular sides of my triangle. 8 and 15. And you could have flip-flopped those. You could put 1/2 15 times 8. Doesn't matter, we're going to get the same number. So the area of the base is 60. Now we have everything we need for our surface area. Surface area is the height times the perimeter plus 2 times the area of the base. And you don't have to memorize that. That's on your formula sheet. 960. Your units are inches squared. Okay, so if you're missing a side and you've got right triangles, think of your old pal Pythagoras. All right, so that was prisms. What about cylinders? Okay, a cylinder has its own surface area formula. Okay, so a lateral area, again, is the area of the sides. Surface area is the lateral area plus the area of the bases. Okay, so lateral area is just the area of the sides. Surface area is all of the surfaces together. Okay, so here we have surface area equals 2 pi r squared plus 2 pi r h. R, of course, is the radius, and h is the height, or the distance between your circles, the distance between your bases. In a cylinder, the base is a circle. So here, the radius is 11. So I'll say 2 pi times 11 squared plus 2 pi times 11 times the height. The height is the distance between the bases, which is 26. I'm going to enter that all in my calculator. You can enter it in one step if you want. Remember to use the pi symbol on the calculator. Don't use 3.14 unless it tells you to. Occasionally, the problems on USA Test Prep will say, make pi 3.14. Okay, if it says to do that, then use 3.14. But if it doesn't say, use the pi button. That gives you the most exact answer. And you should get 2,557.26. Our units, well, this is an area, so it's yards squared. I don't need that S, just yards squared. Okay. Do me a favor, on assessments, please don't put commas. I know that you were taught that this is how you write the number, and that's wonderful. However, the commas mess up my auto grader. So if you put the comma, it messes the whole thing up. So no commas. Okay. Now that you've seen one example, go ahead and try number 10. What's the radius? What's the height? Plug those numbers in, find the surface area. All right, so they tried to be tricky on this one, and they tried to give you the diameter. Hopefully it didn't trick you, right? The radius is half the diameter, so your radius was 7.5. The height is the distance between your bases, so your height here was 9. Think of this as your cylinder just on its side. Plug your radius into your equation, your height into the equation, and you calculate this. Rounding on your very last step, you should get 777.54. Your units, of course, are meters squared. Okay, now that was using the formulas. We can also use those formulas to find some missing dimensions. So in number 11, it says that it tells us the surface area. Surface area of this cereal box is 272 inches squared. Cool, so that's what the surface area is. But we know an equation for surface area. The equation for surface area is 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. If you haven't noticed by now, I make my L's all cursive-y, so they don't look like ones. We don't know what the length is, but I could call that 2 the width and the 12 the height. And so I would say, oh, well, 272 is equal to 2 times the length, which I don't know, but the width is 2, plus 2 times the length, still don't know the length, but I know the height is 12, plus 2 times the width times the height. Now this just has become an algebra problem. 2 times 2 is 4, so I've got 4L. 2 times 12 is 24. 2 times 2 is 4. Times 12 is 48. Combine your like terms. 28 times the length plus 48. Subtract 48 from both sides and divide both sides by 28. So the length here was 8. That length, units, is just inches. So the length was 8 inches. Okay, and number 12, you have a soup can. The surface area of the soup can is 51.84 inches squared. The diameter of the can is 3. What's the height? Can you figure it out? Try that now. So you should have gotten the height of your can is about 4 inches. Okay, your work might be ever so slightly different than mine if you didn't save your rounding for the very last step. Okay, but you should have definitely plugged in your 51.84 for your surface area. If the diameter was 3, that means your radius is 1.5. And you simplify all of that, and you got 4.5 pi plus 3 pi h. You could have typed 4.5 pi into your calculator and rounded it. And if you did, you had some decimal answer that you subtracted from both sides. I didn't want to round until the last step, so I left it 4.5 pi, and I subtracted 4.5 pi from both sides. And then I wanted to get h by itself, which means I had to divide both sides by 3 pi. So I took all of the ugliness that was here on the left, and I divided that entire thing by 3 pi. So in my calculator, I entered this all as one step, which left the rounding for the very last part. If you rounded earlier in the equation, you should have still gotten something very close to 4 inches. Okay, now how about pyramids? Let's find the surface area of pyramids. For our pyramid has one base. Okay, that base has an area, and we call that capital B. So whatever shape the base is, we would find the area of that shape, and that would be capital B. The P stands for perimeter of the base, so we would find the perimeter of the base. And then here's a new one, this script L. This script L means slant height. Slant height is the distance from the point at the top of your pyramid down the side and perpendicular to the side. So here would be your slant height. Your slant height would really be like the hypotenuse of this right triangle if I were to extend this out. And so you should be able to kind of visualize a right triangle there. The slant height would be the hypotenuse of that right triangle. Okay, so we just need those numbers to plug into our surface area formula. So the surface area equals 1/2 times the slant height. We were so nice, it was given to us. If it's not given to you, then you have to figure out a way to find it. Most likely, it'll be Pythagorean theorem. Times the perimeter of the base. Oh, well, the base here is a square. So we have a nice square pyramid here. So the area of a square is side squared. If you recognize it as a rectangle, then you did length times width, and you still got 64. Okay, so that was the area. And now the perimeter would be 8 plus 8 plus 8 plus 8. And what is that? 32. So that goes in your perimeter spot. Now you just calculate all this out. 251.2. This was a surface area, so your units are meters squared. Simple as that. Go ahead and try number 2. So the surface area for number 2, you should have gotten 199 inches squared. Your slant height was given to you, that was 7.4. The perimeter is the perimeter of that square base, 5 plus 5 plus 5 plus 5. And the base is the area of that square base, which is 25. Plug all those numbers into your surface area equation, you get 199 inches squared. Now, number 3 is an example where they don't tell you the slant height. And if they don't tell it to you, you have to figure it out. So I like to draw it in. Here's the slant height. There it is. It is part of this right triangle. All right, well, if I were to redraw that right triangle, this distance right here is going to be half of 16. They tell me the height is 3. Let's find the slant height. Well, hypotenuse squared equals leg squared plus leg squared. So x squared is equal to 73. Now you have 2 choices here. You can take the square root of 73 and say that x is about 8.5. Or if you want a more exact answer, You can say that x is equal to the square root of 73. Okay, I actually used 8.5 on this. I don't know why I didn't go with square root of 73. Either way, we're going to get a very similar answer. All right, so the surface area is 1/2 times the slant height times the perimeter of the base. So the perimeter of the base would be 16 plus 16 plus 16 plus 16. So the perimeter is 64. And the area of the base would be 16 squared, or 16 times 16. Oops. So this is a plus 256. So your surface area here is 528, about feet squared. Okay, don't let the picture fool you. When I look at this picture, that base to me looks like a rectangle. It doesn't look like a square to me. But because they tell me that this length is 16 and they tell me this length is 16, it doesn't matter how it looks. The numbers don't lie. And so the numbers say these 4 sides are 16. So just go with it. Okay, the picture might try to throw you off a little bit. Just go with the numbers that are in the picture. All right, in number 4, I have a triangular pyramid. Okay, the base is a triangle and it's got triangular sides. Number 5 is also a triangular pyramid. And number 6, ooh, we've got a hexagonal pyramid. That'll be fun. But let's start with number 4. What is the slant height in number 4? The slant height is 6.7. What is the perimeter of the base? Okay, so here's your base. What is the perimeter of the base? It's 30. And then the area of the base. Okay, well, that red triangle that I just highlighted is the base of our triangle. The area of a triangle is 1/2 times its base. Okay, so here's the height and here's its base times the height of that triangle. How did you know where the base and the height were of the triangle, Ms. Grandy? I looked for the 2 segments that were perpendicular to one another. Simple as that. Look for your perpendicular segments. That'll really tell you what the height and the base are. Could I have said that this triangle over here was the base? Sure. But then I'd have to calculate the height of my pyramid. Would I? No, I wouldn't. You could have, and just you would have gotten the same answer. Yeah. All right, so we now know that the area of the base is 43.5. So the surface area is 1/2 times L times P plus capital B. 144 units, inches squared. Let's look at number 5. What's the slant height in number 5? Yeah, it's 12.2. What is the perimeter? Okay, here's your base. So the perimeter would be 7 plus 7 plus 7, 21. What's the area of that base? Well, that base is a triangle. So area of a triangle is 1/2. Look for your perpendicular segments in that triangle, 6.1 and 7. So the area of the base is 21.35. Now I have everything I need for surface area. Surface area is 1/2 times L times P plus capital B. So the surface area is 149.45. It's an area, so your units are squared. Okay, let's look at number 6. What's the slant height in number 6? It's 11.3. What's the perimeter? Well, the base here is a hexagon, and each side is 6. I know that each side is congruent, so 6 times 6 is 36. What's capital B? We learned how to find the area of a regular polygon. We could totally find the area of this regular polygon, but look, they gave it to us, so we don't have to go through all of that. It's possible that they would make us do that though on an SOL. So if you don't remember how to find the area of a regular polygon, go back and review that lesson. They tell us here though, so that's nice. And now we have everything we need for surface area. Surface area is 1/2 times L times P plus capital B. And when we calculate all of that together, we get 296.93 yards squared. All right, let's find the surface area of a cone. All right, in our cone, we have a radius. It's the radius of the base there. The base is a circle. We have a slant height. The slant height goes from the tip of the cone down to the base. If I were to draw on a right triangle, it would be the hypotenuse of my right triangle. And then a cone also has a height. The height is the distance from the tip perpendicular to the base. Okay, and we just need to take those numbers and plug them into the formula. So for the surface area, that is pi times the radius squared. In this case, the radius is 7, plus pi times the radius times the slant height. And they were really nice in this first example and gave us all those numbers. I can type this right into my calculator and round on the very last step, 404.64. It's a surface area, so our units are squared. Go ahead and try number 8. Try number 8 now. So for number 8, you should have gotten 1,967.89 millimeters squared. The radius of your cone is the radius of the base. And so since they gave you the diameter of 27, that means the radius is half your diameter. The slant height is the distance from the tip of the cone to the base. So that was labeled as 32.9. So you just plug those numbers into your formula and get your answer using your calculator, rounding on the very last step, of course. Now, what happens if they don't give you the slant height? Okay, well, that means there's a way to figure it out. So in this one, we have the height of our cone is 25.2 inches, and they give us the slant height. Okay, so they did give us the slant height here. They didn't give us the radius. So if you're missing the slant height, or you're missing the radius, or you're missing the height, if you're missing one of those things, then look for your right triangle. Okay, so we were missing the radius here. We know that this is 27.3 and the height of that cone is 25.2. So our dear friend Pythagoras is coming back to play. C squared, oops, C squared, silly me. C squared, that's your hypotenuse, equals your leg squared plus leg squared. And we solve for X or R, whatever you called it in the picture. So the radius of this ends up being 10.5. So now you know the radius is 10.5. You know the slant height is 27.3. So to find your surface area, we'll just take pi times your radius, 10.5 squared, plus pi times the radius times your slant height. And then enter that in your calculator, rounding in your very last step. The surface area is 1,246.9 units, of course, are inches squared. So anytime you're missing one of the three sides, there's a really good chance that you're going to use Pythagorean theorem to find the missing piece. Okay, so now let's look at a couple application problems. We have a cone, and this cone has a surface area of 822.78 centimeters squared and a diameter of 18. All right, they're trying to be tricky and give you the diameter, but if you know the diameter is 18, you know the radius is 9. Okay, let's find the slant height, or L. So surface area of our cone is 822.78. The formula for surface area is pi r squared, r is 9, plus pi times the radius times the slant height. And we need to solve for slant height. So now all we're going to do is just use our algebra to solve for slant height, rounding on the very last step. So 9 squared is 81. So this becomes 81 times pi, because if I multiply it by the pi, then I have to round, and then it's not exact anymore. 9 pi times L. Let's subtract 81 pi from both sides. Now the left side here is going to look pretty ugly. 822.78 minus 81 pi. This is all exact. There's no rounding here. And then I'm going to divide both sides by 9 pi. Okay. So I can enter this in my calculator in one step. 822.78 minus 81 pi divided by 9 pi. That way I only have to round on the very, very last step and I get 20.1. Slant height is a distance. It is not an area, it's just a distance. So our units are just plain old centimeters. Okay, now we have a figure here on the left made up of a cone and a cylinder. And I want to talk about the surface area of that. All right, so I've brought out some visual aids for us here. I have a cone and I have my cylinder. Okay, here it is. If I'm talking about the surface area of each of these separately, the surface area of my cone includes the surface area of this rounded part, which if I were to like unwrap it, it would actually be half a circle, and the circle. So it would be the total area of any surface that I could touch added together. That's the surface area. And then with my cylinder, the same thing. If I were to unwrap this cone, I would see that it's actually made up of a big rectangle and two circles. And if you wanted to explore the equation for surface area, you would actually find that it's actually the equation of a rectangle plus two circle areas. But anyway, you've got the surface of each base and the surface of the sides. So that's the surface areas separately. But what happens when I put them together? There are now two surfaces that I had originally that aren't surfaces anymore. And they're here, these two circles. As soon as I put these together, this circle and this circle are not on the surface anymore. So now I have a surface area that I can calculate, but that's just any part of this outside that I can touch. And those two circles that were originally surface area are now no longer on the surface. So I'm going to have to account for that when talking about surface area. So we have to think about that when looking at this cone and this cylinder. We're going to find the surface area of the cone. And then we're going to find the surface area of the cylinder. But there's two surfaces that we're going to have to get rid of. And that is the surface of the top of the cylinder and the bottom of the cone, which happens to be the same thing. So we're going to find the area of the circle, and we're going to have to subtract that out twice. And you'll see what I mean in a moment. Let's find the surface area of each of these things first, the cone and the cylinder. So let's start with the cone. So the surface area of a cone is pi r squared plus pi r slant height. So what's the radius of the cone? That would be from here to here. Okay, well, the diameter of that circle is 34, which means that the radius is half of 34, or 17. Pi 17. Slant height was given to us at 20. Okay, so when I add or calculate this out, I'm actually not even going to multiply by the pi. I'm going to keep it super exact. 17 squared plus 17 times 20 is 629. So this is 629 times pi. I didn't even round. This is the exact surface area of the cone. 629 pi. Now for the cylinder, we're going to find the surface area of that. That's 2 pi r plus pi 2 pi r squared. There we go. Looking at the wrong place. 2 pi r squared plus 2 pi r h. Okay. So the radius is still 17. And the height of my cylinder is 12. So nice and exact without any rounding, meaning I'm going to keep pi in my answer. Anytime you keep pi in your answer, we call that leaving your answer in terms of pi. Okay. And now let's find the area of the circle. Well, circle is just pi r squared. So that becomes pi times 17 squared. So the area of that circle in terms of pi is 289 pi. So the total surface area here is going to be to take the surface area of your cone plus the surface area of your cylinder, and then subtract your circle, because the bottom of the cone wasn't actually a surface, and the circle again because the top of the cylinder wasn't a surface. So I have to subtract out this area of this circle 2 times because that circle is not actually on the surface. But when I calculated the surface area of the cone, that surface was included. And when I calculated the surface area of the cylinder, that blue circle was included. So I got to get rid of it from the cone and from the cylinder. So in terms of pi, my answer is 1037 pi. Rounded to the nearest hundredth, I would type 1037 times pi in my calculator and get about 3257.83. Your units are meters squared because it's an area. Okay, so just one more time, why did I subtract the area of the circle? This 629 pi represents the total surface area of the cone. This 986 pi represents the total surface area of the cylinder. But as soon as I put that cone on top of the cylinder, the bottom of the cone and the top of the cylinder are no longer on the surface. So I got to get rid of that area so that way it's not actually included in the surface area because it's not on the surface. I hope that explanation helped for this guy. All right. Number 12. The roof on a shed is a square-based pyramid. All right, we've got a square-based pyramid. I'm going to do my best to draw it for you here. Oh, not too bad. If the base has the side length of 10 feet, oh, it's a square, so that means all of these are 10. It was a square. And the slant height of the roof, so that's slant height, that's here, is 9.4. Find the area of the roof. All right, now think about putting that on this roof on top of a building. That square is not going to be filled in, right? That's going to be open. So I'm not finding the surface area here. I'm finding the lateral area. The lateral area is just the area of the sides without the base. Your other option is to find the surface area and then subtract out the area of the base, right? But if you did that, you would end up with the lateral area formula anyway. So if you're looking at your formula sheet, you're looking for lateral area because this base is open. It's not actually a surface, it's open. So your lateral area is 1/2 times your slant height times your perimeter. Well, the slant height was given to you. And your perimeter, well, that's just 10 4 times. So the total lateral area, or the area of your roof, it's 188 feet squared. Okay. So we're finding lateral area here because this base part is actually open and we don't want to include its area. Okay, we got one more shape to talk about, and that's a sphere. Okay, your sphere has parts that you probably already know, but we'll label them here anyway. You have the diameter. The diameter goes through the sphere and touches the edges. Your sphere has a center. Your sphere has a radius. And then this circle that goes through the center, that's called the great circle. And let's see if I can show you an example of the great circle. All right, so here I am again with my toys. I've got a sphere here, right? Well, if you were to cut that sphere exactly at its center, you would have this circle. It's actually called a cross section. But that circle, the biggest circle that you can create by cutting it in half, is called the great circle. So if someone's talking about the great circle, I don't know why they named it that. It's kind of a dumb name. But if someone's talking about the great circle, they're talking about cutting your sphere in half at the center. Okay, on our Earth, we might call that the equator, right? That would be the great circle of our Earth. So with your sphere and your hemisphere, there are equations that go with them. I will tell you that the hemisphere equations are not on your formula sheet, but you can always derive them. Or you could always just, find the surface area of the entire sphere, and then you'd have to like cut it in half. But then as soon as you cut it in half, you'd have an extra circle. So let me just kind of show you how you can get this hemisphere from the sphere equation. So the sphere surface area will be given to you on your formula sheet. If you were to cut that in half, right, 4 pi r squared divided by 2, that's 2 pi r squared. But as soon as you cut that sphere in half, you've now created this extra surface, this great circle. So you have to add in the area of the circle, pi r squared. Well, there's really a 1 there, right? So that is where your 3 pi r squared came from. Okay, so if you're looking for the surface area of a hemisphere, you're going to take your whole sphere and cut it in half, but then you have to add in this new surface that you created when you cut it in half. Or you could memorize this. I don't recommend memorizing it, but you could. Okay, so let's find the surface area of each sphere below. So in number 3, we're looking at the equation for surface area. This is an entire sphere, so I'm just looking at 4 pi r squared. The radius is 2.8. So now I can type this in my calculator. In terms of pi, like if it said to leave your answer in terms of pi, that means don't do anything with the pi except bring it along, like don't multiply by it. So your answer, an exact answer, would be 31.36 pi. If it said to round your answer, then yes, you would round it, then you would multiply by the pi and you'd get about 98.52. Either way, your units are meters squared because it's an area. Okay. So if the directions say to leave your answer in terms of pi, that means just bring pi along, don't actually multiply by it. Your answer will have a pi in it. Go ahead and try number 4. What's the surface area of this sphere? Try that one now. Okay, I didn't leave my answer in terms of pi. I just went ahead and rounded it, and I got 1,809.56 millimeters squared. Remember that your radius is half the diameter. They tried to trick you there. Since the diameter was 24, your radius is 12. Okay. And then our last examples here are hemispheres. So your equation for the surface area of a hemisphere is 3 pi r squared. If you didn't memorize that, that's okay. You just take your surface area of an entire sphere, you divide it by 2, right? So that gives you half of it. And then you have to add in another pi r squared for the surface of that circle that you created when you cut it in half. And then you end up with 3 pi r squared anyway. Okay, so the radius here is 14. So we just have 3 pi times 14 squared. In terms of pi, that's 588 pi. Rounded to the nearest hundredth, 1,847.26. Units for both are yards squared. Go ahead and try number 8. What is the surface area of number 8? Do that now. Okay, so for this one, you should have gotten about 350.7 centimeters squared. You rounded to the nearest tenth. The radius here, of course, is 6.1 since they gave you the diameter. And that brings us to the end of our lesson. So this was all on surface area, just really using that formula sheet and making sure that you're plugging the correct numbers into the correct place. If you have any questions, please don't hesitate to reach out to me. I'm happy to help. There are practice problems available to you on OMHS. And again, I'm urging you to make sure you have that formula sheet nearby, a clean copy, so that you can use it on any assessment. Have a wonderful day, everybody.